All right, so I just pasted in a question at the top there. So why don't you just give it a read through and then we can get started.
All right, sounds good. So given a sorted array and a target value, return the index if found. If not, return the index where it would be. Assume no duplicates. Okay, so I'm just going to write out my approach to this. So let's say that we have an array that's 0, 1, 2, 3, 4, 5. And we're going to be looking for a target. So I'll just pretend that this 3 isn't here, and we'll make 3 our target. So whoops, we don't want that. So the way I would go about this is I would go through each element, and if the element at the index that we're looking at is equal to the target, then we'd return that index. But if say we pass the place where the element should be, then we'll also return that index, because then we know the position that it should be. So for instance, we look at 0, not 0, 1, not 1, 2, not 2. So 4 is greater than 3. So then we know that 3 belongs in this position because it should come right before 4. So
yep.
Yeah, so I think that's going to be my approach to that, and I'll do that using a for loop, and I can do that here with the little implementation. So I'll have a test that says if nums, or we'll start with the for loop. So for int I equals 0, I is less than our size, then we'll increment I. And we'll have an if statement that says if the array at I is equal to it, then we'll return it. But also, if it's greater than our target, then we'll also return I. Is greater than our target, then return I. And if we get to the end of our array and we still haven't found the target, so basically we checked everything, it's not there, we know we have to tack it onto the end because naturally it would come like right after, for instance here, since it's sorted. So then we would know that we can just return the size. So return size, because that size will give us the index that we'll have to put the target at. Yeah, so we don't want that in our for loop though. We'll put it after our for loop, so right here. Okay, yeah, I think that this would be my brute force approach to this.
Okay, yeah, so then for what would be the runtime for this?
So the runtime, since we're looping through the whole array, I'd say that it's a function of n, so linear.
Okay, yeah. Yes, this is good. This is the linear solution. So can you think of any way to make this a little bit more efficient, a little bit faster?
Yeah, so my first thought would be to use a binary search type of approach. So since it's sorted, we know like we could direct ourselves to where in the array we want to look instead of looking at every single element. So I think that I could go about this with a binary search style.
Okay.
So yeah, logic behind that would be just our classic binary search. So we will find our midpoint, and if our target is above the midpoint, then we will shift our focus to basically focus on the left half of the array and vice versa in case it's smaller than the midpoint. So then, yeah, it'll have this iterative way of narrowing down where we will be looking. So I can write out some pseudocode here. Yeah, fine. So we will calculate our midpoint, and we'll say our mid is high minus low divided by 2, with high and low being actual numbers, like elements, not indexes. So yeah. And then we'll say that our low is 0, or we'll be given the high and low. Or wait, let's see. So yeah, our low will be 0. And then our high will be the size minus 1. And this minus is just because of the 0 concept. And yeah, like how I said here, the midpoint will be low plus the high minus low divided by 2. So that makes sense. Yeah. And then as we go through, we're going to see if, we'll just do this initial test. So if the array at the midpoint is equal to the target, then we'll just return the midpoint because that means we're done, quick and easy. But more than likely, that's not going to happen, so we need some other if statements. So we'll say if the nums array at the midpoint is greater than the target, then we will shift what we consider to be the high point, because now we want to look at this left side. So we'll just readjust what high means, and we'll say that high is the mid minus 1. So that'll help us look at the right side. And for the other case, we'll say, not if else, we want else if. Else if the other case, nums at the mid, this is all pseudocode, by the way, I don't mean to be implementing this right now, is less than the target, then we will shift our focus to the right side. So then we'll change what our low is and we'll keep our high. So then our low will be our mid plus 1.
Okay.
Yeah, so yeah, and if all else fails, then we'll just return our low, because that'll ultimately be, after rounding all this down, it'll be our index. So yeah, I could probably start implementing this into a function style.
Yeah.
So copy, I'll just take this top piece, bring it down here. All right, so we will do some initializing. I don't need to actually write that out. Int low is 0, int high, and int mid. So our high will be our size minus 1, like how we set up here. And our mid will be what we said there before. Oh, I don't want it like that, actually. That's better. Nope. Yes, that's what I want to do. Great. Yeah, so then we will start our while loop. So then the while test that we're going to have is while low is less than or equal to high. And we do this because if low eventually passes high, then we know we checked everything and now they're eventually crisscrossing. It doesn't make sense anymore. So that's when we want our program to terminate. And so we're going to do, well, actually, I want to initialize this in the while loop because, do I want to do that here? I think I want to do it in the while loop.
Okay.
Oh yeah, we want to do the while loop because it's going to be changing every time. So we want to have that in here because it's going to be updating. So yeah, so we're going to say this first if statement that I have up here that I will adjust. So if the numbers at the midpoint is greater than the target, then we'll change our high. So that's that. And else if this, else if it's less than the target, then we'll change our low. Wait, is that correct? Else if it's less than the target, then low is mid plus 1. Wait, let me think about this. Greater than the target, Yeah, that's what I want to do. Yep. Okay, so then at the end of all of this, we will return our low. Because yeah, at that last iteration, it's going to reassign what mid is and what everything is. So then eventually we'll be looking at low, and then low will be our last index because everything else would have been changed at this last iteration. So we have this, everything lines up, and yeah, I think that this would be my end solution for this one.
Okay. So now what if we're given some list and our target is 5. So our target is actually in the list here.
So if it's in the list, sorry, could you rephrase that? What do you mean by that?
Yeah, so say so part of the question is that if the number is found in there, then you can just return the index that it's at.
Okay.
So would your solution make sure that it returns the index if it is found? Because I see that on 45 here you have a check for when it's larger, and you have another check for when it's less.
Oh, so we need one for if it's equal. Yeah, so I will change that. So if the array at, since we're testing for mid, we'll just keep with that formatting. So if it's equal to the target, then like how you said, we will return that index. So return mid. Yeah. Or wait. Yeah, and then the other case will return low. So
yeah.
Okay.
Yeah, so good job with this one. So then now what would be the runtime of this one here?
So runtime, we're dealing with binary search. So this would be log of n, because each time you divide by 2, basically. So it would end up being like, yeah, the concept of log of n.
Yeah, well, good job with this one. I think you would have passed there. You had a little slip up there, but you know, you caught it with a quick little hint. So yeah, good job.
Great, thank you.